Three inequalities to get onto my graph. First thing I need to do is remember that in order to show the region, I've got to draw the straight line y equals x minus 1. Now, in order to do that, you can use gradient and intercept. In this case, the intercept is -1, so it might actually be easier to find some points. When x is 0, y is -1. When x is 1, y is going to be 1 take away 1, which is 0, so it goes through 1, 0. When x is 2, y is going to be 1, so it goes through 2, 1. I know it's going to be a straight line, so if it goes through 1, 0, and it goes through 2, 1, then it also goes through this point, and this point, and this point, and this point. So I'm just going to join that up with a line, so there it is, and that's the line y equals x minus 1. Now, I want the region where y is greater than or equal to, so y is greater than or equal to x minus 1. It's probably going to be the area above, but let's just check. So because I'm looking at greater than, so I'm going to just choose a point. So let's say I'm going to choose the point 2,6 just as a quick test. Y then is 6, greater than or equal to x, well that's 2 minus 1. Is it true that 6 is greater than or equal to 1? Yes, it is. So this is the side that I want. So I'm going to shade out. Remember, I shade the region that's not included. So I'm going to shade that side. Okay, right. Next line, x greater than or equal to 2. Now, for the line x greater than or equal to 2, I'm going to draw, for the region x greater than or equal to 2, I'm going to draw the line where x equals 2. It's a vertical line through here. So I'm just going to go straight to the line here. So there's the line where x equals 2. I want the side where x is greater than or equal to 2. So I want this side, so I'm going to shade out the excluded side of the line, which is over here. So let's just shade that out completely. Okay, I'm then going to draw this line, or I'm going to draw the line 2x plus y equals 8. Now, the easiest way to draw that type of line, rather than using gradient and intercept, is to find out where the line cuts the axes. So I'm going to put x equals 0 into this equation. Well, when x is 0, this disappears because 2x is 0, and I'm left with y equals 8. So the line goes through 0, 8. And if the y coordinate, the second coordinate, is 0, this will be 0 because y is 0. I'm left with 2x equals 8, so x will equal 4. So this line goes through 0, 8, which is here, and it goes through 4, 0, which is here. Again, I know that it's a straight line, so I can actually just draw it as a straight line. Let's just go from there down to there. Now, which side of the line do I actually need? Maybe not that obvious. 2x plus y greater than. I want the side which is greater than. Again, I could test a point, perhaps. Test a point that isn't on the line. Well, let's choose this one, which is 4, 6. If I put 4, 6 into this, well, 2x is going to be 8 plus y, which is 6, 8 and 6. Is that greater than or equal to 8? Yes, it obviously is. So I want this side, so I need to shade out everything which is below this line here. So it's just going to be covering up that little region there. And then the question simply says to me, write down the minimum value of y in this region. Well, this is the region that we're talking about. The lowest possible value of y is going to be at this point here. So the minimum value of y, if we just look across here, is 2. Okay, so the second part there says the minimum value of y is 2.